Oh wait, I didn't do a share screen. Hold on. Yeah. Oof. Oh, wait, that would have. This won't take long. I'm not going to let this take longer than 13 minutes. You're not in a big hurry. You're not in a big hurry. All right, good. Good thing. Oh wait, my board's dead now too. So that's okay. I can fix this. Let's see. Maybe it's just this. Hey, we're still alive and kicking. This is good. All right, let's get through this. I'm going to try a different approach with you guys. Like I said, I grade myself when I teach, and I'm very honest with myself. And earlier, I gave myself a very generous D minus. So today we will be writing equations of lines for what, if you feel like this is like the 13th straight day, you might be right. We've been doing this a long time, but this sort of wraps it up. This concludes it. Today we write the equations of what we call parallel. I'm going to write with my proper handwriting here. Parallel and the other word that you might not be familiar with. I know, as always, we're not always consistent as teachers in what we give our classes. And so when you come to me, some of you are very familiar with that word, some of you are not. So let's start with the one that I know you know, and that's parallel. Two lines are parallel if what?
They run in the same direction.
Right. So there's a little bit of an addendum to that. They do have to technically lie in the same plane, but yes, they're lines that just never intersect with each other, bottom line. And they do have to be on the same flat piece of paper. So like if you picture a line like this and a line like this, you see my two pens, they never cross, do they? But they're also not parallel, you would agree. So that's why when you go over to Mr. Manlove's class, he'll make sure when you get your definition of parallel that it's two lines that not only lie in the same flat plane surface, but that also don't intersect with each other. What makes two lines parallel? I mean, I understand it's because they don't cross, but let's talk more about algebra stuff. What makes two lines not cross? It's something we've been talking a lot about for the last couple of weeks. What would make two lines, Hunter, never cross each other? No. Yes. What makes two lines parallel right here, and this is definitely going to go in your notes, is two lines are parallel if they have the same slope. So, I mean, like if, Zach draws a line and his line goes up to right three, up to right three, and then Shanessa comes over and says, hey, I'm going to make a line that's perfectly parallel to yours, then she's going to move somewhere else on the graph, but she's still going to go up to right three. So by having those identical slopes, the lines will literally, by definition, never cross each other. Do we agree? Okay. This one's a little bit more abstract. So I'm getting all the definition-y stuff out of the way first. I thought the lesson might go better if I'm more organized about this. So do you guys know what this word is, perpendicular? Perpendicular. Just I tried to write neatly so you don't misspell it. Perpendicular. What makes two lines perpendicular? Sutter?
Two lines are being and 90 degrees.
Right. Very good. You got that quickly. That went much quicker than it did earlier today. So you either know that word like from experience or for whatever reason, or you just don't. But there's like hundreds and hundreds of examples of perpendicular lines all around you in this room right now. They're all over. So again, they're two lines that cross, but when they cross, they very specifically cross at a perfect 90-degree angle. Okay, can we agree with that? So for this one, this one's a little bit tougher for me to define. I guess what I'll write for now is yes, they cross at a 90-degree angle, but that honestly isn't what's going to get us through today's lesson. It's all fine and good, and Mr. Manlove will love that stuff. But for me today, your algebra teacher, I need to know, what does this look like on a piece of graph paper? So for this, let me bust out a piece of graph paper, my fake digital piece of graph paper. Imagine I had a line that went like this. So what I'm trying to accomplish with this diagram is I want to show you a line that has a very particular slope. And you could probably see as I was writing it, but you can I did miss the mark a little bit. Let's just pretend that my line goes through that point and that point and that point. I got a little bit lazy, didn't I, with my graphing? So let's assume that those are all lattice points on my graph. What would you say is the slope of that line? Very good. And it's definitely positive. So we can all agree, I hope by this point, that the slope of that red line is 2/3. And I know I don't have arrowheads on it, but that's okay. I just want the slope. Now, if I was going to graph a line that's perpendicular to that, it has to have a look to it, a certain look. It has to make that perfect cross 90-degree angle. And so for that, it would definitely be negative something. I appreciate you saying that. If I do negative 2/3, I'm really glad you said that. Let me do that, and you'll see why it's not correct, but it's one of the best things I've heard anybody say all day, which I know sounds weird because it's a wrong answer. But take a look at these two lines and tell me, I hope you agree that those don't make a right angle, do they? So you can learn from this experience. Like I said, I'm super glad you said that. So just taking a slope and saying the negative version of that slope will do isn't good enough, is it? Do you agree that the blue line needs to be a little steeper? Okay. Anyone want to take a guess as to what the slope would need to be? Andy? What do you mean by that? Could you be more specific?
So like,
You done this before? Nice job. Good reasoning. Excellent mathematical, like in the moment thinking and reasoning. You do two things to make a slope perpendicular. And you guys, that was an excellent team effort there, Andy and Kennedy. That was excellent work. So one of you figured out, well, it's got to go downhill, so it's got to be negative. And the other one of you kind of pieced together that since it's got to be steeper, just take a look at this real quick. If I do what Andrew said, if I actually flip the slope over, then not only, I don't know, I guess where I want to go with that thought, but I make it steeper, but I've taken the 2/3 and just literally switched the position of the numbers and made it up. Do you guys remember what that's called in math when you flip a fraction over? So there's a word for it. Yeah, that's one word. More commonly, it's a word that starts with R. It's the one you guys learned first when you're young. Do you remember that one? When you flip a fraction over, it's called the reciprocal. Yeah. So I hope that kind of gets stuck in your head there, but take a look at these slopes. And if I haven't bored you to death already, just take a look and buy it for yourself. Look at those points and look at the slope of the blue line. You can see it for yourself. It's down 3, right 2. Right here, you can see down 3, right 2, whereas the red line is clearly up 2, right 3. So if one slope is 2/3, the other slope is the opposite of that, and then also flipped over. Are you with me so far? Okay. So let's get to what this is going to look like when we do actual math problems now. So what we're going to do today, I'm going to take off my graph paper. We're going to write equations of lines under a very different set of conditions. And so as far as examples are concerned, here we go. I want you guys to write me the equation of the line that passes through the point -4, 15, and is parallel to the line y equals 1/2 of x minus 6,426.4. Repeating. Take that. Whenever I teach this, I try to go out of my way to make the y-intercept of one of the lines obnoxious enough that you get a very certain clear point. So here it goes. If I'm asking you to write me the equation of a line that's parallel to the one that I gave you, what has to be true about the line you're about to create? It needs to have what very specific slope? You can be more specific. As the line that I gave you. Good. And what is the slope of the line that I gave you? Good. So if you can picture this, you really go in, you kind of just sneak in like a burglar, and you take the slope of the line that's given and you steal it, and then you use it for your own endeavor. And I do think my board just died, so I'm just going to plug it in real quick. But so what I want you guys to do now is think about, like, how many times have you done this in this class? Like a lot, right? That's all we've been doing. So think right now, could you write the equation of a line that passes through the point -4, 15, and I gave you the slope of 1/2? Could you do that? Well, of course you can. So that's what I want you to do as I find power. It looks like a lot of fancy new stuff, but in reality, at the end of the day, I'm giving you the slope. I'm giving you a point. It's no different than any other level 2 problem. Do you remember how we called them like level 1, level 2, level 3? That's what this is, just a level 2. So you guys good? So in other words, as my board died, the slope is all we want. What are we going to do with this negative y-intercept down 6,462? What do we use it for? I hear you saying things, but I can't really hear you. Sir?
Maybe, second point.
Nope. We don't use it at all. So I see that I probably should have made that number bigger to drive my point home. Have you ever heard of someone going to like a junkyard and buying a car for like $800 when in reality they just want one part on it? You ever heard of someone doing that? Like that's how I view this. That I'm not a car guy, but that's kind of how I feel about this is like I don't want the whole equation. I just go in, I sneak in, and I take the slope from the line, and I say, all I want is your slope. So I sneak in, I grab it, and then I do the problem. So here it is. So I might have lost you by now. I can't really tell, but do you understand that all I'm really asking you to do is write me the equation of a line? And I have given you the slope. I'm just doing it, and I've done it in a very strange kind of way. Good. So which method do we like better? Do we like this method where we would put y minus 15 equals 1/2 of x plus 4? Or do more of us like the method that we learned yesterday where we write y equals mx plus b? Hands for the first way. I like it the old way. I don't want to change it. Hands for the way we learned yesterday. Wow, see, you guys are dead opposite of first tower. That's very interesting. Maybe it's the way I teach, maybe it's the time of day. But okay, then I guess the masses have spoken. We're going to stick with the second method then. So going into this problem, we already know that the slope is a half, so that makes that easy. It's not even really a split. I know the answer. I'm going to write it in green. I knew right away the answer was y equals 1/2 x, right? Now I just got to find b. So quickly help me. I'm terrible with my fractions. What's half of -4? So I have 15 equals -2 plus b. Add 2 to both sides. What's b? The answer is presto, boom, right there. I realize that's a lot of talking to make a very simple point, but when I give you parallel, all I'm asking you to do is take the same slope, use it, and move on your way. All right, let's do another one. This time, let's write the equation of the line that passes through the point 10, -14, and is perpendicular to the line y equals 5x minus 264,129.36 with the 6 repeating. Okay. Thought maybe if I made the number a little bigger this time, you would, next time when I ask you, you'll answer the question correctly. So here we go. I've given you a line and you don't have to really picture it, but the line that I've given you is very uphill and steep with a slope of 5. So what's the slope of my line going to be? I don't want that slope. I want a different one. What's it going to be? Close, Steve. That was a good try, like for real. And that's part of it. Hunter? No, Steve was onto it right there. And having done this before, you're supposed to say that at least once or twice. It's very common to think that, oh, I remember he said just to flip the slope over, right? But there was something else to that too. Kennedy and Andy teamed up on it, remember? We have to also make it a negative, or if it were negative, make it a positive. So think about it like this. You slip in, you grab the slope from this line, and you say, I'll take that, thank you very much. And you observe that that slope in its current state is 5/1. And then you do what we call the switch flip. The technical term for it, I think, is this. You're supposed to call it, you ready for this? The opposite reciprocal. I don't care if you never utter those words in my presence. All I want to know is that you know how to do it. And so the switch flip. So I take the slope in its current 5/1 state and I say, hey, let me switch you. I'm going to flip you over to 1 and 5, and I'm also going to put a negative on you. So let me ask you again, what are we going to use the -264,000 for? Absolutely nothing. Very good. The only part of this equation that I came for was the slope, the 5. Nothing else matters. And so at this point in time, I look at it like, again, something I've done 119 times already. I've given you a point. I have indirectly given you a slope. Let's do this. So to write the equation of the line, the answer I know is y equals -1/5 of x. The question is, what goes in this box? And we do that, we find that by doing our little y equals mx plus b trick from yesterday. So what is y equals mx plus b going to look like for us in this case? I wasn't ready for you. I'm so sorry. Yes, -14 equals -1/5 times 10. You guys are excellent. Good job. Plus b. And then you got to do a little bit of basic math. What's -1/5 times 10 right here? -2. So I have -14 equals -2 plus b. Add 2 to both sides. What's b? Perfect. And there, guys and gals, is your equation. Good. Okay, there's one more little trick to this, and this, oddly enough, is the easiest part that I guarantee will become the hardest part. Riddle me this. I don't know why it happens, but here we go. I want you to help me write the equation of the line that passes through the point 56, -49. It is parallel to the line x equals -13. Sorry if I've lulled you to sleep. Please give me like 3 more minutes. I promise I'm almost done. This is not a math problem. I'm going to say that again. This is not a math problem. You don't have to multiply. You don't have to do any fractions. You don't have to flip anything over. This is not a math problem. This is a who's listening problem. So here it goes. What kind of line is that? Good. This has nothing to do with math. That's a vertical line. I gave you one. And if I want you to give me one back that's parallel to this, what do you give me back? Another vertical. And how do you write the equation of a vertical line? Done. Problems like that should take under 3 or 4 seconds, like no exaggeration. If I give you a vertical line and I say, hey, make me a parallel one to it, you just make me another vertical line. What if I gave you the same exact problem over again, but I changed the word parallel, you know where this is headed, to the word perpendicular? Good, Adam, very good. So this time I'm giving you a vertical line. That's important that you identify that. This is not find the slope, slope undefined. Just don't make a mountain out of a molehill. This is a vertical line. And if I ask you to make me one that's perpendicular to this, you make me one of these. And how do we write the equation of a horizontal? So my answer is done. Like easy peasy. So the top 6 questions on the worksheet, the lines are all parallel. The bottom 6, they're all perpendicular. And if you have questions, you just got to let me know. I imagine you'll get it done today. Tomorrow, the schedule is going to be a little weird. I'll stop the recording, but then I'll talk to you a little bit about school tomorrow and what it's going to look like, even though we're not really sure just yet. Let's see. Stop.